Hey there, fellow engineering enthusiasts. Today, we're diving into the fascinating world of gears. Get ready to learn about the different types of gears and how they work, all in just 3 minutes. Let's get started. First up, we've got spur gears. These are the most common type of gears you'll see. They have straight teeth and are mounted on parallel shafts. The cool thing about spur gears is their simplicity and efficiency. They're great for high speed and high torque applications, but keep in mind they can be a bit noisy. Next, let's talk about helical gears. Unlike spur gears, helical gears have teeth that are cut at an angle. This design helps in reducing noise and vibration, making them smoother and quieter. They can handle more load and run at higher speeds than spur gears. The angled teeth also mean they engage more gradually, which is better for the gear's longevity. Now, on to bevel gears. Bevel gears are shaped like a cone and are used to change the direction of a shaft's rotation. You'll often find them in applications where the input and output shafts need to be at a 90-degree angle. There are different types of bevel gears, like straight, spiral, and hypoid, each with their own unique benefits. Then, we have worm gears. These are fascinating because they consist of a worm, which looks a lot like a screw, and a worm wheel. Worm gears are excellent for reducing speed and increasing torque. One of their standout features is the ability to provide a locking mechanism, which prevents the gear from backdriving. This makes them perfect for applications like conveyor systems and lifts. Don't forget about planetary gears. These guys are a bit more complex. A planetary gear set consists of a central sun gear, planet gears, and a ring gear. This setup allows for high torque transmission and compact design. You'll find planetary gears in things like automatic transmissions and electric screwdrivers. So, how do gears actually work? The basic principle is pretty straightforward. Gears transfer motion and torque between machine components. When two gears mesh, the teeth of one gear push against the teeth of the other, causing it to rotate. The size and number of teeth on the gears determine the speed and torque of the output. For instance, if you have a smaller gear driving a larger gear, the larger gear will turn slower but with more torque. This is crucial for applications that require precise control and power management. And there you have it, a quick rundown on the different types of gears and how they work. I hope you found this information useful for your engineering journey. If you enjoyed this video, don't forget to hit the like button and subscribe for more awesome content. Thanks for watching, stay curious and keep engineering. Motor Geek,